Okay, so I'm now going to talk about the predict product worksheet. Number one, which is the displacement. Just let you know that I will talk about this part at the top part in one video, and then the bottom part with the reason and word on different video. The back part is the same thing as the front part, the bottom. So I'm not gonna do this on the video because this exactly the same thing as here. But the back, we don't need to do the reason part. Okay, so I will just talk about this part right now, and then this part will be on another video. So first is we need to use the solubility rule to make sure that we can label the states of the matter successfully, which one is aqueous AQ, or solid S, or it is precipitate PPT, and give you the reason why. So we're going to use, just give me a second, so we're going to use this solubility rule, okay? We already discussed about that, okay, in the other video. So basically, I can write some notes here. So when is aqueous, AQ, is when it is soluble. Okay, soluble will be aqueous or AQ. Okay, now solid and precipitate. Okay, solid and precipitate, they both insoluble. They're both insoluble. But when do I say that I will say it is solid? When I will say that is precipitate is when the compound is insoluble and it is reactant, okay, then it's solid. When the compound is insoluble but they are on the product side, then we will say precipitate, okay? And then this part of the reason is based on the solubility rule. So the first 4 questions are already done for you. So, for example, ammonium nitrate, it is a reactant. So we look up the nitrate part, okay? We always look up usually the negative part. I mean, except ammonia, okay? In other words, we always look up the anion part except ammonia because ammonium shows up on here too. So let's say, do we have nitrite here? Okay, we don't have nitrite. That means we want to look for ammonia. Okay, we don't have nitrite, so we're looking for ammonia. So ammonia, say ammonium are soluble in water. Okay, so we say that the reason here is ammonia are soluble. So we just copy ammonia are soluble. We copy from here onto here. Okay, so since ammonia are soluble, it is always aqueous, no matter reactant or product. Okay, now calcium sulfate, we look up the negative one. Okay, so we look up the sulfate one, and the calcium sulfate is on reactant. So sulfate are soluble except Ca2 plus. Okay, sulfate are soluble except Ca2 plus. So we write that down. Okay, sulfate are soluble except those of Ca2 plus. Okay, we write this down, and then you ask yourself, okay, sulfate are soluble except Ca2 plus. So when do you need to write the except part? Is when you see this shows up, then you have to write except. If you don't have Ca, you have something else, that is not part of the exception, that you don't need to write. But here we have Ca, so we have to write sulfate are soluble except those of Ca2 plus. So it means sulfate usually are soluble, but except Ca2 plus. So on the other hand, it means that CaSO4 is not soluble, is insoluble. Okay, SO4, CHSO4 is insoluble. If it's insoluble, then we will come back to here. Insoluble, it is a reactant, so it must be a solid. Because why do we say that the reactant is a solid? It is because the reactant does not start the reaction yet. We just take out some product, we just take out some solid from the bottle. We haven't started the reaction yet, so we say that it's a solid. So we say that it's a solid. All right. Now the potassium sulfide, so we look up the sulfide one. Okay. So sulfide. Okay, so we write sulfide are insoluble, right? Sulfide are insoluble except those of group 1. Okay, so sulfide are actually, did I look up the wrong thing? Sulfide are insoluble except group 1. Oh, I forgot to type insoluble here. So this should be insoluble. This should be insoluble. This is the error. Okay? Sulfide are insoluble. Alright? Because it is written from here. Sulfide are insoluble except those of group 1. Because potassium is group 1. So it means that potassium sulfide are soluble. Okay, so if they're soluble, it is always aqueous. Okay? And finally, aluminum phosphate. So aluminum phosphate, we look up the phosphate one. So phosphate. Phosphate are insoluble. Okay? We don't have aluminum here. So we don't have the exception. So phosphate are insoluble. So phosphate are insoluble. Now if it's insoluble, we look it up. Okay, it's a product, it's a reactant. Okay, it is a product. If it's a product, do we have to say precipitate? CPBT. So why we say that the product is precipitate is because the product is like the one after reaction. After the reaction take place, something precipitated, settled down. Okay, so we have to use precipitate to describe the product. Okay, now we can try to do the following 4 questions. Okay, so MgS. So we have to look up the anion. Okay, MgS reactant. So MgS, S is sulfide. Okay, S is sulfide. Okay, S2 minus. So S2 minus are insoluble except those of Mg2 plus. Okay, so we gotta write S2 minus are insoluble except those of Mg2 plus. So S2 minus are insoluble except Mg2 plus. So it means originally it is insoluble, but exception is Mg2 plus, so it means soluble. Soluble, this is parenthesis aqueous. Okay. Now next one, AgCl reactant. So we look up Cl. Okay, so chlorides are soluble except those of Ag plus. Chlorides are soluble except those of Ag plus. So Cl minus are soluble except those of Ag plus. So it means Cl are all usually soluble except I have Ag. That means it is insoluble. Now if it's insoluble, it is reactant. That means reactions haven't started yet. So it must be a solid. Okay. Right. Lead-2 chloride product. So we look up the chloride one. Okay. So chloride are soluble except Pb2 plus. Now we look it up Pb2 plus. Lead-2, so it match. Okay, so we gotta write chlorides are soluble except those of Lead-2. Chlorides are soluble except those of Lead-2. So chlorides are soluble except Lead-2 chloride. That means it is insoluble. Insoluble, it is a product. So product is after reaction take place. So it must be PPT because precipitated, settle down. Zinc bromide. So we look up bromide. Zinc bromide, it is a product. So bromide bromine are soluble. I don't have any exception thing for zinc. No exception, right? So we just write bromides are soluble. Bromides are soluble. So bromides are soluble. If it's soluble, it is always aqueous, no matter reactant or product.